All right, welcome everyone. Looks like we've got about a minute before the hour, so just want to start this a bit early and give some folks an extra few minutes to join. And I know that we've got usually a lot of returning guests at these, but for any newer folks who haven't been to one of Acelab's webinars before, my name is Bo. I am going to be hosting today's event with Linda Potter from Hohmann Barnard, who's going to be giving our presentation today on thermal innovations for wall assemblies. So I'm going to give a few minutes of a quick tour of Acelab, as well as just some info about how to get information after the event, how to submit your AIA number to us, and all of that good stuff. And I'll get started with that quick demo and tutorial in just a moment or so. And then that'll only be 5 minutes before we'll jump into thermal innovations. All right, looks like we've got quite a few folks here already, so I will go ahead and get started with our quick intro. All right. So for anyone who's not familiar with Acelab, we are a product selection platform built by architects for architects, with the goal to save you design time and allow you to discover, organize, and collaborate on your product specs all in one place. So as I said, we are built by architects for architects. So this is a snapshot of our team. You might be familiar with Christine from some of her building science courses. I'll also show you where we have some of those courses on our site. And Dave was the former CEO of Revit. Varden and Dries are our founders, and Varden, Dries, and I all have worked in the architectural field as well. So yeah, as architects, we basically believe that our time would be better spent designing and problem solving rather than making endless phone calls to manufacturers or trying to track down product information in old project folders. And that is where Acelab comes in. So I'm going to jump over to our live site. I will sign in really quick. So if you don't have an account, super easy to make one. It's also totally free. You can sign in with Google, so it's super quick. Once you have an Acelab account, anytime you sign in, you will come back to your library dashboard. So you get a quick overview of all the work you've been doing on Acelab. Here we'll save your recent search activity. So if you ever don't save anything, you can always get back to it. We've got some safety guards in place there. And then we also allow you to save your own searches. So you can see here, I've saved a few different searches. And this works really well as a way to start aggregating product lists. So if I want to save, the high performance doors that are available in North Carolina and are multi-slide, I can create a product list of that and basically save it as a search that I can always go back to. And then of course we have a product library as well, so you can save products. And I'll jump over here to my library in the top right. This is where you can kind of start to store and organize all that information that you're seeing on your dashboard. So the first thing I'll jump into is the project portal. Just to show you real quick, this is kind of the main place where you can start to set up your organization on Acelab. It's a pretty flexible platform, so you can organize this however works best for you. As you can see here, I have a few residences. I also have some projects called general research and firm standards. Basically, projects work as folders, so you can use these to kind of organize your products as you are finding them through Acelab. I'm going to jump into one of these projects just to show you all of the things that you can do under here. So here you can see I've saved some products to this project. They are tagged with the project that I've saved them to. And this is also filterable by category. I can also save my searches and conversations. And I want to jump over here to show you project info. So it's really easy to upload projects on Acelab. We only ask 4 questions, but anytime you want to come back and add additional details, this also works really well as a place to save and store your project information. So you can upload CAD files, renderings, drawing sets, all of that good stuff. And then in the next few weeks, we are going to be launching our collaboration functions. So pretty soon, this will be fully collaborative. You'll be able to add and invite all of your team members, your contractors, anyone who you'd like to have access to this information and to be able to save products, have conversations just like you can. And then I'll jump over here to show you this conversations tab. So this is something that will be helpful to know as you are finishing this event. So if you want to get in touch with someone, you can do that directly through Acelab. You can see here that I've started a conversation with our speakers from today. Over here on the left, the project details are saved, so everybody has a quick overview of what we're talking about. If you're not doing an active project, you can see here I nested this under general research. So that's a great way to kind of just enter your general inquiries. And we also ask you to submit exactly the information you're looking for. So we want to kind of cut out some of the noise and allow you to really get the information in the data that you need. So we'll always ask you to, put in exactly what you would like to hear from these manufacturers from. Then I'll just jump over here to show you, basically you can get to all of your saved information on Acelab either by going to your projects and viewing what's nested under there, or if you just want to get a general overview of everything that you've done, my library on the top right has these general categories. So this is all of the products that I've saved on Acelab across all of the projects. They're tagged with the projects that I've saved them to, so I can see if I've saved them in multiple places or if I haven't used them for a specific project yet. And again, this is filterable by category. Same thing here, searches and conversations. Also, you can go and get a full general view. I'll save showing you that again. And then I just wanted to mention, so up here we have all of our search tools. That's how you'll actually find these products. I won't jump all the way through this. It's pretty self-explanatory, which is the great part. So it's a very visual guided search tool that allows you to really narrow down your product selections in a way that allows you to, have a more guided approach. And then if you know exactly what you're looking for, you can always come over here to the search bar in the top, type in the name of the manufacturer that you'd like to find, and you can find their full brand page on Acelab. So these are our speakers for today, and something that I wanted to mention during the event, I will share this link to the manufacturer page so everyone has access to it. If you would like to connect with the speakers, request product data, you can come here anytime during today's webinar or after. You'll be asked to nest it under a project or create a new one. I'll just do that real quick so you can see how quick it is. And again, this is just to give them some information about your location and your kind of, general inquiry that you're looking into. So that's all there is to do to create a project. Now I can submit my request for price quotes, lead times, even samples, certifications, really whatever I want here, connect with the expert. And that has made a conversation. So that's saved in my Acelab account. I can come back to it anytime, check on the status. I can also send attachments back and forth. So those drawings that I'm using in my projects can also use to collaborate with product experts here. All right. So that is it for my quick tutorial. I've got a few more things that I want to mention about today's webinar. So this is an AIA-approved event. We did not ask for your AIA number upon registration yet. We're doing a new system for those of you who have been here before, where we're going to ask you to sign in now that you're here. So I am now going to send over a link to everyone to just fill out a quick form with your AIA number. Do this anytime throughout the webinar. And you'll also get this link later on in case you missed it. There you go. All right, so I just sent that in the chat to everyone. That's your form to sign in with your AIA number. Make sure you do that so that we can get you these credits. A few other things I want to mention. So the Q&A, we can save some time at the end for questions. If you have questions during the webinar, please feel free to submit them now or as they come up. I'll be keeping an eye, so if anything seems urgent, I'll pause our presentation so that we can answer it, but we'll try to save most of them for the end and have a bit of conversation. All right. So with that, I think that's all for me. Linda, if you're feeling ready, you can go ahead and start presenting. Oh, and everyone, actually one more thing. Here's that link to connect with Linda's team. So if you have any, specific questions, you're like, I want product literature, feel free to use that link and submit that request. And we'll also have a quick poll at the end of today's event. So stay tuned for that. All right. So that's all for me. Linda, feel free to take it away.
Thank you, Bo. This is so fun because I've worked for Hohmann Barnard now for 3 years, which means basically all of COVID time. And I live in Nebraska as a remote employee, but also take calls and help architects all across the US. And it's been one of those things that we've asked ourselves, how do we connect with all of you in a way that is as timely as you need us to connect with you, to, as helpful as we can be? What does that look like? And we were like, who's making the next platform? And I feel like this is such a great thing for us to be able to connect. So very grateful to be here. So happy to be part of this. And today, so we're going to be talking about thermal innovations in wall assemblies. And so that's the biggest thing we ask ourselves as manufacturers. We charge ourselves with the need to see the pain points that you're having when you're designing. Where are we going? Where's the industry going? We better have a pulse on that. We better be years ahead of what's needed in development and research, so that when you have to design in a certain way, you have the products that you need to do that. And the biggest thing is you as a manufacturer could have the solution, but if we can't get that in front of you and you don't know about it, it's not useful or helpful for anyone. So the hope today would be that we present you with some new innovations with thermal efficiency in mind for different ways to develop walls. So I am an animated speaker, so I'm going to shut my video off so you can pay attention here. But again, I'm so happy to be talking about this. Anytime you need to put the questions in, I'll stop and we'll get started, okay? Let me see if I can find how to I don't even, okay, here we go. Here we go. Again, AIA HSW seminar. And where we're going with this is we know that thermal innovations are necessary. Your energy codes are evolving. They're getting more strict all of the time. We're going to talk about some different design strategies that exist in case you weren't aware of them. So you can ask yourselves, do I have everything I need? Do I feel equipped to design with thermal bridges in mind as we start to be in a world where every thermal bridge has to be accounted for in a wall? What do I do about that? If I still want to use brick or stone or concrete masonry products in a wall assembly, but then also, how does that look as we start to lighten things up and as we move into rain screens and the buzz about that? Because we know that brick, as it has existed in cavity walls, is your first rain screen wall assembly. And so these are all kind of the same conversations of how do we get high performance buildings. We're going to talk through anchors and the impact they might have on your R value of your project, offset shelf angles, a little bit about high performance air barriers, and then some rain screen attachments and how all of this relates to what I need to do if I'm looking for a thermally efficient building. Everything that we'll talk about comes from industry resources. You know, it's not this is what Linda Potter thinks. This is not what we're here for. We're here for understanding what is the single source of truth, if that exists, because we all know that there's a lot of different ways you can do things. I'm not here to say this is the only way, but everything that we have to present today is based on industry standards, industry information that exists out there for you to know about. So if these websites aren't things that you know of, feel free to jot them down, use them. They're there for your benefit. The biggest question that has happened in terms of innovation, if we think about brick anchor ties, is the introduction of exterior continuous insulation. We then had to ask ourselves, okay, if we are adding this exterior insulation, be it rigid board, mineral wool, spray foam, however you're choosing to put continuous insulation in your walls, we now have to have an anchor that fits that wall assembly. So what happened is you saw an anchor on the left in a wall section, as you see here, which was typical Soldel. There was all the place, you know, your anchor needed to be attached directly to your sheathing or to, you know, making positive connection to the backup. And that was typically what was used in all these walls across the US. We add continuous insulation. Now you need us to change the anchor to fit that. The first way that we approached that was simply taking that anchor and adding prongs that would cut through that insulation and allow us to still make that positive connection to the backup so that we could give those tension and compression values as that push and pull of wind load existed, that we could keep that there. But what you see here is, I hope all of you are seeing a whole bunch of opportunity for air leakage. And that's what we've come to find out is that, well, yes, this anchor meets code structurally. It's not doing much at all. In fact, it's very invasive for your building envelope design, that we really think that there's a better way. And there have been innovations since this. So again, you're kind of seeing this penetrations and how they matter. And we're looking at, if we've got these prongs here, top and bottom, we've got 4 thermal bridges. We're adding a fastener at the top and the bottom. We're now at 6 thermal bridges through the insulation, through your air barrier, without any approach of sealing that back up. Sure, we could look at using some tapes, but is that really going to give you the peace of mind that your building envelope is functioning the way you expect it and design it to function? We see on the right the picture of what it would look like as a barrel anchor was introduced into the market, and how that has limited your penetrations through, has provided some seals at those crucial moments that we're penetrating, and how that obviously appears to be a better solution for a building envelope building enclosure, which is what we really care about if we care about thermal efficiency in a building, right? So one of the things that is highly debated inside the masonry industry is how invasive, or what is the quantifiable way of saying, what do these anchors do to our overall R value? We do a lot of speculation. We do a lot of, I think, or common sense would tell me, but we wanted to know real data. And so this is a study that was done with a leading firm to help us understand the thermal impact that anchors give. This was done before I came to Hohmann Barnard. So this was done 10, 12 years ago, where we took at the time our best functioning, or what we thought to be our most thermally efficient anchor on the market, which was that barrel anchor. And we have the ability to, but it was in a zinc, so galvanized metal there. We're not in stainless steel at this point. And we ran that through and we said, okay, what happens if I space this at 8 inches, 16 inches, and 24 inches? And I put it through 1 inches, 2 inches, 3 inches, 4 inches of insulation. What does that do for my overall R value? We're going to look at the 16-inch. So in the middle of this table, we're going to go all the way over to the right. And you're going to see at 1 inch of insulation, we're at 90% efficiency in our wall assembly. Honestly, that's pretty good. We're not doing a whole lot of impact there. But we move up to that 4 inches, we're at 81%. And again, this is with a single thermal bridge, single penetration. And we start to say there may be some truth to these thermal bridging, that while they're small in terms of what they are and they happen often, they, depending on what you're using for that anchor, could really impact that overall R value, which is why we really have to start saying, I'm going to control what I say I want used in my building, because if I leave it up to a contractor, they may not understand my design intent, and that you may get one of those anchors that has those 6 penetrations and really messes with your air barrier and your insulation and lots of air leakage, which is far more of a problem than just the thermal bridge of the anchor. But you can see how there's a lot of things that these anchors themselves will impact, and how you need to start to look at these with a little more understanding of what you have access to and what you want in this building. What we did for innovation is we changed that from a zinc anchor and changed it to stainless steel. We put a UL 94 coated plastic, if you will, nylon coating over the top of that to give it a true thermal break. And so you're going to see 2 different iterations from us of this type of an anchor. There are other manufacturers. There are thermally broken anchors on the market, in case you weren't aware of that are being used all across the US and all markets, widely accepted. And you're looking at this from 1 inch to 4 inches, really this 90 to 93% efficiency, which is really something I think we can all stand to live with. I think you're also watching a lot of code, depending on where you're designing, that are making you do thermal breaks. And so these anchors exist. They're here for you. They've been vetted. We've thought through them. And something to consider when you think about thermal bridging. Now, the other thing that we have to mention is just in general, changing from a zinc anchor to a stainless steel anchor, or galvanized to stainless steel, does a lot of thermal benefit as well. So I know that there are times where I can't use a barrel anchor because maybe it doesn't fit my wall assembly. Just moving that anchor to stainless steel can really impact that overall efficiency of a building. We get asked this question quite frequently. I'm probably in at least 3 conversations with building envelope consultants, and we're really trying to understand this anchoring. And there's this questioning coming up of these barrel anchors and the blind connection that looks like. And so we do want to talk about plate anchors real quick. And I want to talk about this is an anchor that isn't going to be isn't a big offender to that insulation like the previous anchor we saw with those prongs that builds all those holes in there. But I don't have a true thermal break. So I'm putting this anchor on before I'm putting my insulation, and then I'm fitting my insulation in between those anchors. So it's a change of sequencing, but that's means and methods for our contractor, right? Maybe that's not that big of a deal. I'm not getting a true thermal break here, but if I move it to stainless steel, I'm doing better than if I weren't concerned about this thermal bridging concept. So we have started to see some building envelope consultants say, I like this idea of not having a blind connection where I'm trying to go through the insulation and hit the stud. Do I trust that it can hit the stud? Do I trust all these things? If we are at that space, because again, I think that there's more than one way to do something, I'm here to equip you with different ideas to think about things and let you make what makes sense, that decision that makes sense for your firm, for your design of what makes sense. We have started to see where maybe on the back of that anchor, we're going to put some sealant on there and we're going to wet set that in place and then use a gasketed fastener through those and try to really make a good seal and a connection that I can trust and I can see. You know, to each your own. These exist, but there is not a true thermal break here. We were asked like, hey, what would it look like to put like a thermal shim on the backside of this plate? We have the ability to do that, but you're potentially pushing that anchor off of the wall. And are you doing any amount of that insulation's not now snug, tight against that backup in every one of those locations where we've got this convection loop potential? What's the impact of that versus not having that shim there? I don't have any true data to give back, but maybe something if it's needed, we will look at doing. We want to partner with you, make sure you have everything you need to keep moving forward when you design with brick, when it makes sense to use it, that you have what you need to continue to design in that way. But truly, when we look at anchoring, we really want you to think about, what am I doing to my air barrier? All of those penetrations are always what we have in mind. So, you know, if you're still using a CMU backup for years and years and years, the typical way of doing that was with an integrated joint reinforcement and anchoring system that you see on the left, where I can control that eyelet coming out of that block to the depth of the insulation. I'm still fitting that insulation in, but 2 birds, 1 stone. Now I'm just connecting the anchor when I lay my veneer up. The thing about that is that I often get a lot of air leakage around that eyelet coming out of that wall there. So now I need to, if I'm going to get a really good air barrier install, if I do have leakage there, which a bubble dome test would tell you, I've got a lot of detailing around each one of those eyelets in order to really stop that air leakage coming through that air barrier. So what you see in the middle is what these barrel anchors with seals that are thermally broken will do, is that they seal at that inner air barrier interface and seal at that insulation. So we're seeing one fastener through and we're sealing at both of those locations. So we can really start to say, am I stopping and treating any penetration through? So things to think about with anchoring. The last thing I want to leave you with in terms of anchoring is just a real quick code update from TMS 402. Now, this is a change that happened in the 2016 TMS code, which was adopted by 2018 IBC. If y'all are beyond the 2018 code, this still exists, but if you're below that, you might not have this option yet. So what happened is, prior to 2018 IBC, you were allowed 4 and 3/4 inch of back of brick to your structural backup. And that was your cavity width that you were allowed prescriptively. If you went beyond that, which we did a lot, you just needed an engineered review or an engineered judgment, maybe some delegated design if you had really wide cavities. So we were doing wider cavities, but what happened is we moved that up to 4 5/8, so you allow for that sheathing. And then also you have up to 6 5/8 now that you can do, provided that you need a couple of things. So your spacing is pretty much going to go to a 16 by 16, and you're going to the part of the anchor that, so the barrel depth of an anchor couldn't be the airspace can't be any more than 2 inches. So you know the code allows you the 1 inches of airspace. You're allowed no more than 2 inches now if you're going prescriptively, and the majority of the rest of that 6 5/8 cavity, if it's not airspace, needs to be the part of the anchor that's like the barrel or the plate, not just the pintle or the hook. So that hook can only bridge 2 inches and then into the back of that anchor or that brick. So that might have been confusing. It's never been that confusing for me to talk about before. So you're welcome. But the reality here is that we've designed cavities 24 inches at times with anchors. And that's a big takeaway here, is that sometimes that's new for folks to hear, is that I think I look at this and I think I'm limited by code. I can't do anything outside of 6 5/8. And so if I want to play with my brick design and I want to bring that brick proud another 4 or 6 inches to give some shadowing lines and to kind of play with the depth of the building and add some cool features, which brick allows us to do, I have to move my backing to go with that. And that's just not true. We can oftentimes figure out how you can leave that backup in plane, and we can move that facade in and out however you need to, and corbel it or do kinds of things that we can do that with anchors. We just have to know that if you're beyond that, you're going to want some judgment, you're going to want some consideration. We'll supply you with testing and we'll help you figure that out. Your takeaways are: know what you want on the project, specify it. Don't allow your contractors to decide this. What you have to do when you're selecting an anchor is you've got to know what is your wall system. What insulation are you using? How much airspace do you have? Are you using sheathing? We're seeing a lot of movement away from what I would say is a typical wall assembly, where we've got sheathing then steel stud. Now we're saying, okay, there's insulations on the market that allow me to remove the sheathing entirely. And that is now my air barrier strategy and my insulation and my structural component in front of my studs. But now these anchors fit in this a little bit different. We can work through all of that. We have options, but know what you're dealing with. Consider that the penetrations to your building envelope, that's the most important thing when you're considering anything thermal, if you really want impact. And then the sequencing and impact this anchor that you choose has potentially on your means and methods of your contractor. So lots of things to think about. We're always a step away if you need help working through that. But so often I've heard, I don't get involved with the anchoring side of things. I just let the contractor figure that out. And I hope that what you've seen here is we really don't want to leave that in the hands of the contractor. You decide what you want. It's all about the building envelope. We're going to move right into shelfangles, which are the most offensive thermal bridge that I've seen in a masonry wall building. And so what you've seen is you've got your increased mass to accommodate those wider cavities. You've got that continuous contact with the building that has a lot of thermal transfer. We're interrupting continuous insulation. We've got all kinds of challenges with how we do the air barrier. And so you've seen this. We wanted to quantify again, what does that look like for actual thermal impact? So RDH did a study, and we started to look at this and understand, how do we help this? So what they did is they looked at 3 different scenarios. You may have seen this study, but with a steel stud backup, with a poured concrete backup, and an exposed slab edge. And we looked at the thermal impact these are having. So you see an effective reduction of R value by 63.5%, 37.5%, 46.4%. These are really large offenders. I don't know that you can keep adding insulation to a wall and making up the difference of what this one part of a building will do, which is why we've seen movement towards these offset angles. We've seen them with knife plates, designed with structural tube steel. We've seen overlapping angles. There's a lot of different ways that engineers over the last 10 years have been designing these systems so that we are allowing that less surface connection for less thermal bridging, because we know we've got to structurally do something at these shelf angles, whether we're holding the weight above an opening or whether we're trying to allow for that brick to expand. We've got to give these relief angles in our buildings if we're doing brick multi-story. So what are we going to do about that to help you? What this study the RDH found is that when I push those angles off of the wall, we're now down to a reduction of effective hour value to about 16%, 15% in some moments, which we think is something we can live by. That's far better than what we had before. That the summary, what RDH found was that effective R value reduction of 40% for the full wall height assembly when cutting through the insulation, 40%. Adding thicker amounts of insulation can't overcome that thermal bridging. It means we have to make a design change. It does not mean, oh, we can't use brick anymore. That's the main takeaway here is you've got a lot of options to design with, but we know what brick does. We know that we can trust it. It's something that has been around for thousands of years. We don't want to just say we can't use this anymore because we can't, it's not thermally efficient. So what do you have now? Well, we want to dive in and say what you have now when you're doing offset shelf angles on site is that typically we're seeing something welded in place with an angular tube. There's not adjustability. We've got coordination between trades, which is a demanding, difficult thing to have happen and have done well. We've got difficult details. We still have a lot of mass. We still haven't handled anything with the air barrier detailing. And so what you have now at your fingertips and have had for the last 5 to 8 years, maybe even 10, is proprietary standoff shelf angles. You're not having that welding on site. It's engineered and manufactured specific to job conditions. You get in and out, up and down, left and right adjustability, which matters for you because when you think of brick, we think of aesthetics. That's usually why we choose it. We choose it because it's durable, but we choose it because it's beautiful. And so if you allow a mason to install their shelf angle and give them adjustability, now when they have to try to course that brick out to fit those openings, now they have some extra ability to do that instead of what you sometimes see is really wide mortar joints or really thin mortar joints. You start to see some of these ugliness come through because of the details of what they've got to do to hit certain heights as they story their brick out. So it allows us to change the sequencing. That air barrier can go on first. And so we can get a truly continuous air barrier. And then we can install the shelf angle and just detail around those small brackets or penetrations. We've got simpler detailing. We have custom angle sizes for the project needs, depending on what you have. And so when it comes to what you have, there's 2 different types of proprietary systems I've seen out there. One looks like a bracket. One is a fin type of style. Why would you use one versus the other? You're going to use, there's several things that we'll go through here. Typically, just a rule of thumb, if you were curious, the bracket tends to be easier to work with. It can handle more stack height. It offers more design detailing for other things that you might not have thought that you could achieve with solutions. But the fin system on the right is about 10% more thermally efficient than the bracket. So there's some things to think about. What do I care about most, which might decide whether I use one system versus another. You can also add shims back behind there if we want to do a true thermal break and we want to get about studies have shown us an extra 3 to 5% by putting some type of a thermal shim back there. The thing that's interesting about this is when we talk about shimming the back of an anchor that only is concerned with in and out positive and negative wind loads, we're not talking gravitationally loaded. We have a completely different shim that's needed in compressive strength to this structural connection. That's why you're not seeing a huge change there, but it is an option. We can do it because sometimes we just need that true thermal break as a give back in a project. But the thing about these is that there's some misconception about what this is. It's very simple. Think about it as a traditional shelf angle you've been doing for years and years and years. These can connect to structural steel, slab edge, bond beams. There's all kinds of different ways we can attach them. Largely, we decide based on one, what your backup is, but two, which type of system are we using and what kind of movement is necessary? Do we want to have embeds? Do we want to do post-installed? Some of that's going to depend on if you're using something post-tension slabs or if you're doing pour stops, or what we're working with for the structural backup might dictate some of this. But all of that is done in design that you can trust these proprietary solutions will figure out for you. Some of these unique ways that these can impact your project in different ways than just the thermal bridging of a shelf angle is that oftentimes we might have these wide cavities with an exposed soffit. So as you look up, all you see is airspace, insulation, a whole bunch of guts of the building. What are we doing to hide that? Because maybe you've got a storefront connection below it or something else that's happening there. We can design with cover plates below there so that we cover all of that, give yourself a nice place for all your mortar net, all of your accessories to happen back behind there. Those are available. So if that's a concern, that is something that we have worked through. What if oftentimes when we had these connections, you had to put that shelf angle where the structural connection was. But what if I want my horizontal expansion joint above that slab edge? I can invert this angle and allow you to do that. What if I've got a tight spacing and I am concerned about flashing? That's the number one thing that we talk about. As you make changes in one way, you add difficulty in other ways. We're not saying you're not. So flashing is things that people talk about a lot. This modified bracket allows all of the guts of that bracket to be inside of that insulation so that the flashing has a nice space for it to be up there. You're not worried about it rubbing on the edges and potentially puncturing that flashing. You can kind of see how that's detailed out here in this detail. My favorite solution, though, we've done a lot where we've been able to simplify details. When you can simplify details and constructability, you really get a better chance of getting a building that's better, right? Keep things simple for a contractor. They tend to do it well. We can drop these brackets. There's been one that I just talked to engineering on last week that we went 66 inches in dropping that bracket down to where they needed that. So maybe we drop to a window head or we drop to a horizontal expansion joint below that slab edge that gives you, because sometimes those window openings are wider than what a loose lintel can handle. What do we do there? How do we figure that out? These allow us those solutions. And they've also modified this bracket to where they don't need to, the back plate of this image is already changed, which shows you how fast innovation can happen, is that the back of that has been cut off this bracket. So they only have this U shape at the structural connection. And then it's just these sides that go down to hold that. So you're removing some of that extra surface connection and thermal bridging as well, which is really great to know that we're always mindful of that. We're checking ourselves with data. We're putting what we hope to be good solutions out there for you to utilize. But one of the biggest things when you think about thermal efficiency, even if we remove thermal bridging off the plate, is this ability for it to sequence, the ability to put that air barrier on completely before those angles get put on. which leads us into this air barrier discussion of understanding continuity matters more than anything else. There's a lot of ways that you can strategize, that you probably are using in how you handle your air barrier of your project. Continuity matters more than anything else, no matter what you use, whether it's sheet applied, spray applied, whether it's insulation or taping joints. The continuity of that is what we care about. I'm sure you've seen this image in this conversation if you've listened to any type of webinar from the Air Barrier Association. And what we're seeing here is there's this, do we need a vapor barrier, or do we vapor permeable? And what about the ability for that material to allow vapor to move through it? And we seem to worry about that. But you can see here on the image on the left, there's really not a whole lot of water. There is water. We need to worry about it, but we need to worry more about what happens on the right, which is any puncture, opening, hole, gap, missed detail around openings, penetrations that don't get detailed, that allow for any air and water to get through. That is a far worse than asking ourselves, how are we controlling what happens with the vapor moving through these barriers, right? Because what we found is in the studies that have been done, this vapor flow in walls matters. And so I don't want to say that it doesn't matter, because we all know it does. We know higher moisture levels equal higher heat loss. So long-term exposure to high moisture conditions can cause damage to building components as well. So if we know that we're allowing vapor in and we have materials that are going to be in a wet environment, we know that there are consequences to that. When we allow something to dry with ventilation and there's the ability for us to have this vapor flow, we allow for drying. The drying is what is high performance, when we have that ability to let the vapor move where it's going to move and keep things dry. There's widely been conversations about where is it appropriate to use a permeable barrier versus an impermeable barrier. I remember sitting in 2005 around a table of architects and asking ourselves, where do we put the vapor barrier? I'm in Nebraska, so wherever we put it, it's on the wrong side half of the year. Which way do we do it? And there was this big debate. You guys still might be having that debate. But what research has found is that we thought at one point climate, humidity, and temperature dictated what we did with versus permeable or not permeable. There are studies out now that have looked at all the different types of walls. They've looked at it in all the different climates. And what they've found is that it depends. And it's maybe one of the most frustrating 2 words you've ever heard, because it doesn't offer you much guidance. Meaning anything can work if you've considered all of these different things. So with things that you can ask yourself, what do you need the barrier to do? High and low permeance barriers can work in all climates. So permeance in terms of, are you going to totally stop that vapor flow? Where are you putting it in the wall? Or are you going to allow that wall assembly to breathe and have vapor permeance, and we're allowing that to go in and out? The entire wall has to be considered. Everything from what's the interior? Are you putting wallpaper there, a vinyl wallpaper that's going to be a vapor lock, so that if you're allowing vapor through, but it hits that wallpaper and now it stops and turns into moisture, and now you've got a mold problem behind your wallpaper, or what you have for your outside facade, everything that happens in the middle of that, from insulation type to air barrier type, all of those things need considered as you start to understand, what am I going to do for this building envelope? Which is why we've seen such a huge increase of those building envelope specialists that can help you. If we're not sure what to do here, figure out what I'm going to do for my main basis of design of how I'm building, based on where I'm located and what my humidity is and where I'm at and what types of materials my clients like me to use. You're going to figure out what that works for you. Just know that when you're looking at different barriers of plugging in a specification, not all barriers are equal. I know you know that, but things that we're thinking about even beyond the building science of this is saying, hey, do we have open joints? Are we doing an open jointed Rainscreen facade, and that UV is going to be all the time on my barrier? Do I have a barrier that can handle that? Construction timeline becomes increasingly something we're considering. I need fast tracking products that aren't going to take a long time to install or to cure or run into problems. Rain is a big issue where we talk about how frequently do you have rain storms that come through that might wash off a barrier that just got installed because we weren't expecting it. Those are common. I don't know that they're common, but they're problems that we have to be thinking through in terms of what am I willing to do on this project so that I remove any potential issues that come up during construction, because we know time matters to everyone, including your owner. What is your owner expectation? Do they have net zero? Do we want something really high performance? You might need to look at a vapor permeable barrier, which means you might need to look at everything else in that wall of how we're putting things together. Do you have differential movement concerns? Do you have a barrier that's going to allow the flexibility that your building will encounter? So you've got some different new technologies on the market that you might not know much about. STPE is vapor permeable. It can be applied to a damp wall. So if you're in a part of the country that is something that is common, so we can't install barriers until we have a totally dry surface, which puts this time frame delay of projects in place, maybe you need to look at something like an STP that can go on a damp wall because it cures with the dampness. It offers long-term UV resistance. It can be applied down to 10 degrees. It's a single coat application. It's got high solid content. These are kinds of things that you might look for if these are pain points for you that you might consider in your specifications. Silicone, vapor permeable, again, all high performance barriers will be vapor permeable because we know what happens when we allow things to dry. It also has this long-term UV resistance. It's got a wide temperature range of application. So I think of cold weather construction that we just got out of. Hopefully we're out of. Can we keep working so that the barriers don't slow us down? Single coat applications, the primerless adhesion, they keep that elasticity. They move with the building. We know and understand silicone from sealants of all over for your glazing. Use that same technology in an air barrier, and you can understand how any of those hairline cracks that might form or any of that movement that happens because we've got multiple materials that we're building a building out of now, and how they come together. We need to understand what that looks like. It's also a fast track project friendly product that can keep and move your project forward. We're going to move right into Rainscreen attachments because, again, what we're seeing a lot of is as we're moving to these lightweight, thin materials, sometimes open jointed systems, it's a big deal to consider the air barriers behind it, which is also why we've got to have something that's high performance for you in there that you feel like will 100% of the time stop that air and water movement, because if you're allowing that moisture in there, now you've got to rely on that air barrier as almost a waterproofing. Although I don't want you to think of air barriers like waterproofing. We know they're different. We know that we've got to understand all of these things, which is why we've moved into learning more about what you need from a Rainscreen attachment. In our research of trying to decide what would it look like for us to take our knowledge and expertise in anchoring facades to buildings with thermal efficiency in mind, how could we move that into something that you might not have access to currently, because we've seen the growth of facades that are out there that you can pick from with Rainscreen. So what we found is that a lot of them are bulky aluminum connections with high conductivity. They're not easily customized to project conditions, meaning you lose that flexibility to design a building to fit maybe the site that you have to work on if we're limited to not having to be able to work with radiuses or certain angles. Oftentimes a lot of these manufactured proprietary Rainscreen systems fit 90% of your building. But what about that 10% that's unique? That's also the wow factor. That's also the part that's going to set my project apart and give me what I want. Now, who owns that? Who helps you figure that out? Those are things that we want to be able to help you with. We know there's different parts for different scenarios. So there's lots of these parts and pieces, which always came back to what we heard so much in masonry walls, is saying there's all these bits and pieces and all these different things that have to fit together and make work, and all these manufacturers and all these options. We know that that can sometimes feel intimidating and overwhelming. And so we thought, is there something we can do there to help out or innovate in this area? Also, we lack this engineering data for project specific opportunities. So what do we learn more about this then? Is the biggest thing with Rainscreen attachments is this thermal conductivity. When you're working with aluminum, it's highly conductive. And what would it look like for us to introduce what we've been doing in the anchoring world for a very long time, of introducing something stainless steel? So what you have now for more innovations are stainless steel connection for back to the backup, the structural connection, with still utilizing aluminum rails. So this technology, this innovation exists for multiple manufacturers. Know this is out there. If you're working with aluminum structural parts now, what would it look like for you to consider something more stainless steel, more thermally efficient? What those are going to allow you to do is we're reducing thermal transfer by having that piece, that structural piece, be stainless steel. We're not interrupting that insulation, and we're reducing the number of fasteners and thermal bridging. We are allowing up to 100 inches before midspan connections are needed, because stainless steel is stronger, so we can do more things with that. We offer fully engineered solutions for your project conditions, accepting any Rainscreen cladding system. We're going to work with your panel that you choose to work with, and figuring out what do they need from us to connect that together. Those are parts that we'll coordinate and work through. They are going to allow these in and out adjustability. We can powder coat or anodize for the aesthetics. If you are going to see back behind that, because it's an open jointed system, we can customize them to your project conditions. But there's also just these brackets, this universal bracket, this need to take all these parts and pieces for left or right or horizontal or vertical or corner or end, or all these different SKUs that contractor might show up with. What would it look like to have one bracket that could do all conditions? And so that's what's been released on the market, that's out there in stainless steel, that allows you to customize that depth to the insulation needed on the project. It accepts any aluminum rail system that's out there, any of your facades. You can install both vertical and horizontal with it. It reduces that thermal transfer still. It's got these dual fingers. It's silly. These dual fingers. What do these fingers do? When I first got introduced to this, it's ease of installation, but also there are absolutely left-handed installers in the market. And wouldn't it be nice if they could use their dominant hand to drill into these things, because they could orient them in the way they needed to still go on the building? Or also, if you get to the end of a wall, you can kind of change it and make it fit. There's a lot of customization here in one single piece, so that you're not slowing down or reordering parts, and all about timeliness and thermal efficiency in a building. So there's a lot of new things out there. We know we're increasing the amount of insulation used in projects. We know that you're looking at thermal bridges. You're being forced to look at them, and only more is coming. So here's some thermal innovations, hopefully today, that you didn't know about or learned a little bit more about, so that you have and you feel equipped to keep moving forward with design.
Awesome. Thank you so much, Linda. That was great. We've got a few minutes left, and I know we've got some questions in the Q&A, so I'll go ahead and start reading some of those out. Before I do that, I'm just going to go ahead and launch our poll for today's webinar, so please fill that out when you get a chance. It's really helpful for us to get some feedback. And then we are also asking there if you would like follow-up information from Linda's team. So that's our safety guard to know who's interested. But as I shared earlier, it's very helpful for us if you can go ahead and put those requests onto the site. So I'll just go ahead and resend those links, because I heard that some people couldn't see them after they had joined. So here, this first link is to connect with Linda. So if you have specific questions, you'll just get answers more quickly if you go ahead and put those through the site. It helps us out with tracking things. And you can also go ahead and answer on that poll. So just in case, we'll follow up with you. All right, let's take a look at some of these Q&A. You ready, Linda?
Yeah, let's do it.
Okay, so the first one, Jack asks if you could talk about the effects of a building being under positive or negative pressure.
So I'm not entirely sure exactly the context we're talking about here, but what I will say about what I was talking about is it's largely misunderstood that veneer anchors are carrying the weight of the brick, and they are not. We are relying on the gravity of those bricks being stacked up to hold the weight there. What these anchors are doing are keeping them attached to the wall. So they're doing as wind loads come in, it's trying to pull the brick off of the wall or push the brick in. What these anchors are doing is holding them where they need to be. And that's the only thing they're doing is covering that lateral movement. So maybe that answers that question. If not, send me a message directly and I'll answer that a little different.
Cool. Yes. Yeah. Feel free to send messages through to the platform. Also, just to mention, once you get past that kind of checking your request off, you can message Linda whatever you want through Acelab as well. So you can, ask specific questions too. And if we don't get to your Q&A, we'll have a record of these so we can follow up with you after the event. Let's see. Ethan asks if you could talk about the cost difference between thermally broken shelf angles and a more traditional welded and tube system.
Yeah, it's a really good question. It's the first thing that comes back, right? How does this impact cost, especially in today's world where everything impacts cost? I don't have a case study, but I want one. I'm gonna push for everything I have to find one in the next year to really look at side-by-side analysis. Here's what I know. We already are doing, there's already an angle, there's already attachment. The only thing we're doing is adding a bracket and maybe some engineering cost. So, but what that's doing is it's giving back money on, there isn't heavy equipment needed on a job. We're talking about a mason's labor rates versus the iron workers' labor rates. Those are things that are probably going to vary based on the region you're in. But we're also talking about minimizing air barrier detailing and also saying what kind of energy savings do you potentially actually give back because you get that air barrier installed on first and have something continuous where we're not having this complete bridge that's impacted everything thermally. So then what's the price of that? So we like to say these are likely something close to cost neutral, but I don't have facts to back that up. So I would love a scenario where we could play this out to actually get that figured out.
Cool. Okay, so Benjamin asked if they could get an example, the chart that you shared, which I think I screenshotted at one point just to make sure I knew what we were talking about. But
is it
Benjamin,
the air barrier one? It probably is the air barrier one with the different wall assemblies. It is a study that is out there that I believe was done by Momentive, but I can share that study if I need to. And if there's a way to put that, if people want to have it as a resource, we can sure get that out there.
Totally. Yeah, I was going to say, so somebody earlier had asked if we can, if they could access these webinars later for reference. So you can. All of our past webinars are uploaded on Acelab. I will send that link over in the chat right now. So we'll upload the recording of this event a day or so after the event, and we could include a link to that resource there as well. Okay. See, we've got 2 minutes left. Could you share an example of silicone barriers?
So there aren't many manufacturers that will do a silicone barrier on the market. To my knowledge, there are 3. And a lot of that's just because the technology of getting that silicone in itself is there's only a handful of them in the world. So you'll find one from H&B, you'll find one from GE, you'll find one from Dow. Seem to be the only ones that are silicones on the market right now that you can look at.
Okay, cool. Let's see. So does H&B design and supply the anchors, standoff brackets, and shelf angle for the TBS system, or is the system just the anchor?
Yeah. Ooh, that's good. I will clarify that for future seminars. Thanks for that feedback. Everything from H&B is complete. Everything from the fastener to the shims, to the design, to the angle itself, to the brackets. Every part of that embed, whether it's post installed, everything is full stop shop.
Okay, cool.
Time.
Yes.
Is the industry catching up? Yeah. Yes, this is the thing. I think that we're getting caught up, but also it's a coordination thing, right? So sometimes it's not the lead time of production, it's the lead time of design and shop drawing approval. So there may be instances where if we have something that needs something sooner than what you're hearing, it may just need to be a coordination meeting between the contractors so we can expedite some shop drawing phases. That seems to be what's the biggest holdup, isn't our ability to fabricate. It's the in-between of constant design change, which is a thing, and then making sure that we have the time in order to do all of that. So some of that is just coordination, but I do think that we're getting better at it.
Cool. Okay, and I know we are at time, but we've got one left. So we'll just, if we can, if you've got a moment, Linda, we'll go ahead and finish it. Let's see, does increased air cavity depth affect wind loading from greater or less cavity pressures?
I don't know how well I can speak to this with 100%. What I will tell you is I'm on 2 committees with the Rainscreen Association in North America, and we are talking about the cavity depth behind Rainscreen walls and how that impacts fire. Because you think about just it's a greater area for combustibility. So I don't know about, I say that to tell you this cavity depth is something I'm learning more about in terms of how what that's doing to the actual building. I don't know about wind loading of that cavity pressure. And if I do, I forgot it since I learned it. So I can get that back to you if you really want to know more about that.
Well, yeah. If that's important for you to know, feel free to put in a request for that info and we'll get that to you as well. Okay. So we are a minute over. We did great. And I'll give one last call for questions just because I see there's still a few people who stayed on with us. But if you have follow-up questions after the event, again, head on over to Acelab, submit them through that portal, and you'll be able to get in touch with Linda really quickly over there. Okay. Cool. Well, thank you everyone so much for joining. Really appreciate it. Linda, thank you for the presentation. That was great and super informative. And yeah, we'll look forward to doing our next webinar together. And thank you to all of our attendees. We hope to see you at the next one. All right.
Thank you.
Well, have a good rest of your day, everyone.